Hi everyone. So this is the e-learning schedule. Yesterday was a day to work on your test review. I tried to pick problems that I'm guessing most of you guys had done already, or at least done half of it, especially since some of them were right in the beginning. And then that way you didn't have as much to work on. Also, there was no notes for that day, which then means you didn't have to do notes and homework. So I'm hoping that this kind of gave you a reprieve day on the first day. When we get back to school, we will start by spending time on the test review. Um, we'll kind of play that by ear, but we'll have a couple days working on the test review before we take that test. Um, so we're just going to kind of start this next unit now and just kind of keep going as far as we need to go. Um, but yeah, so our first day here, we're going to talk about literal equations. You're going to notice that I did some skipping here, like here's number 1 worksheet, here's 4, 5, and 6. Some of those days might end up just being cut throughout the year, or they're days that had to do with graphing or things that I thought would just be better spent with me teaching in the classroom and not through a video. So we won't go in sequential order of what the unit was supposed to look like. Okay, so do your best. If you can print out the notes and work through them, obviously that's ideal. I totally get though that some of you guys either don't want to waste paper or don't have a printer to print it out, in which case just, write on a scratch sheet of paper. You will have to do a little bit more writing than what you're used to, but you also have a little bit more time too. So, but I am sorry that I didn't get these copies to you before we left and before all this happened. So we're going to talk about literal equations today. If you look at this document that is in the Google Drive folder, in that e-learning folder that I created, if you click on these are hyperlinks. So if you click on it, it's going to take you to where you need to be, but it's also, I organized it for you so that it's going to say day 1, and then there's going to be notes in there. There's going to be filled in notes in there. There's going to be, I'll put the answer key in there. So everything that you need will be in there, but it's also in the Unit 5 folder as well. If you have questions, just feel free to email me. I'm going to post everything on Google Classroom. So if you guys have questions, feel free to post on there and everybody can kind of respond if somebody has a response for you. I'm also going to look into Google Hangouts so that I can find a time where I can live stream with you guys. And if you have questions, I can just answer them through that. Okay, but I will be looking into that and I'll give you some times of when I'll be available. Okay, we're going to do everything we can to make sure that we all get this, even though we're not in the classroom. Okay, so here's our notes. Again, write it out if you don't have it printed out. These are just solving. And remember, at any point in here, if you want to pause and work through it on your own and then check your answer, you don't need to go one by one with me. Okay. If we want to solve this, we're going to want to multiply by the reciprocal. We're going to multiply by 5 over 2. Multiply by 5 over 2. Okay, so that's going to leave me on the left side with 2x minus 6 equals 14 times 5 is 70. 70 divided by 2, or we could do this too. This is 14 over 1. So 14 and 2, this, if I cut them in half, this becomes a 7, and this becomes a 1, and 7 times 5 is 35. Okay, I'm going to add 6 to both sides. I add 6 to both sides, which gives us a 41. And then I'm going to divide by 2, which gives us a 41 halves. Okay. All right, this one, solving an absolute value equation. The first thing we have to get this absolute value by itself. So that's my goal, get this by itself. So first I'm going to add 1 to both sides. I'm actually going to change this into a fraction of 1/4. That's going to be x plus 9. So if I add 1, that's going to give me a 3. If I multiply by the reciprocal like I did in the last one, I'm going to multiply by 4. That's going to leave me with x plus 9, the absolute value of that, equals 12. Remember, when we have absolute value, we need to break off into 2 equations, since we can take the absolute value of 2 things to get a 12. I want to know when is x plus 9 going to give me 12. I also want to know when x plus 9 is going to give me a negative 12, since the absolute value of negative 12 is also 12. If I subtract 9 from both sides here, I'm going to get x equals 3. And if I subtract 9 over here, I'm going to get x equals negative 21. So both of those values will satisfy my equation. All right, over here I have fractions. These are not yet like terms. They are like terms, they just need common denominators in order to multiply them. So I'm going to make the common denominator 21, which means here I'll be multiplying by 3 over 3, and here by 7 over 7. So 3 times 4 is 12 over 21x. And then over here, 7 times 2 is 14 over 21x. And then I'm just going to leave this as 13. I can add these now since they have common denominators. So 12 plus 14 makes 26 over 21x. Remember, don't do anything to the denominator. Denominator stays the same. So just like in the last ones, I can multiply by the reciprocal. See, that's kind of the common theme here. So if I multiply by the reciprocal, I can use a calculator here. But I'm going to kind of work through this and show you guys that you don't need a calculator for most everything that we're going to do. So I'm going to change that to a fraction. Then I can see 13 and 26 are my numerator and denominator. So I can divide by 13. That's going to make this a 1, and that's going to make this a 2. So 1 times 21 is 21 over 2. And that would be my final answer. Okay. A lot of what this unit that we're going to cover, all of these lessons in these next 4 days, are actually really good lessons for SAT practice. And you're going to actually notice that within the notes and the homework of these days are SAT types of practice questions. So anywhere that I found SAT types of questions that fit this content, I put them into the notes and homework. So inherently, it's going to help you guys with the SAT when we return. So please make sure that you take your time with those. All right, solving for literal equations just means that we want to solve for the variable that's being asked for. So in this case, it says to solve for y. So if I want to solve for y, I first need to move this term to the other side. So I'm going to subtract 8x. Okay, that's going to leave me with negative 3y equals negative 8x plus 48. We typically write the variable first, which is why I'm rearranging these terms, not writing 48 minus 8x. I need to divide by negative 3 here, and that means I need to divide all of the terms by negative 3. That's going to leave me with y equals 8/3 x minus 16. And you can see I'm leaving it as 8/3. I'm not rounding it, not making it something with a 3 repeating, but also it's linear. So linear, I always want to leave it in slope-intercept form. So rise over run. Okay. Over here, I want to solve for a. Whenever we have a fraction, remember we never touch the numerator. We always have to get rid of the denominator first. So I'm going to multiply this whole side by 3. I'm going to multiply this side by 3. So the 3's will cancel here and leave me with y plus a equals 3c, number first. If I want to get a by itself, I need to subtract y from both sides. So I get a equals 3c minus y. And you could flip the order of those terms if you wanted to. You could say negative y plus 3c. All right, next, solve for x. So solve for x. Notice that I have a term on the left side with an x. I also have a term on the right side with an x. So the only time that I can, when I have terms that are not alike, notice that's going to be a 4x and an fx. I need to actually get all of my terms first. So I'm going to distribute here, and you're going to see what happens. I'm going to have fx plus b equals 4x plus 4cg. Okay, I'm going to move my x terms to the same side. They're not like terms, I can't add them, but I can move it. So I'm going to move this term over by subtracting it. And I'm also going to move this term to the other side too. So I'm going to subtract b to both sides. That's going to leave me with an fx minus 4x equals 4cg minus b. Because these both have an x in common, I can factor an x out of it. So f minus 4 equals 4cg minus b. Okay, so my goal is to get the terms with the x's to the same side so that I can factor it out. Because I factored, I've created multiplication. So then I can undo the multiplication with division. So I can divide by 4, or f minus 4, on both sides. That means on the left side I got x equals by itself. On the right side, there's nothing I can do with this. I have a c, a g, a b, and f. There's nothing that I can't factor, so I can't cancel anything with the f minus 4. So I'm forced just to leave it actually as is. So my numerator will stay 4cg minus b divided by f minus 4. Okay, all right. Number 7. Remember, as you guys are filling this out, if you're working on a separate sheet of paper, make sure you pause it, write the problem down. Feel free to try it and then listen. But at the very least, pause it, write the problem down. Notice that I have a fraction equals a fraction. This goes back to math 2. This is when we cross multiplied like this. That means that I'm going to do 6x times 3 equals 5 times 2x plus 8y. Okay, so I'm just trying to show the distributive property here. 6x times 3 gives me 18x. Over here, I have to distribute to both terms. That's going to give me a 10x plus 40y. You notice I didn't even actually look at what I'm solving for because cross multiplying had to be my first step anyways. I want to solve for x, so I'm going to move this term over. So if I subtract 10, that's going to give me an 8x equals 40y. I divide both sides by 8, and that's going to give me a 5y. And there we go, we've solved for y. All right, and the next one, same thing. This would be a good one for you to try on your own. It's a proportion. We have a fraction equals a fraction, so the only thing I can do is multiply. Okay, my goal is to get t by itself. So if I cross multiply, 9 times t is 9t. And then over here, I'm going to have 8, and I'm going to distribute it to both terms. So 8 times r is 8r, minus 8 times 7 is 56t. And I do want to solve for t, so I'm going to add 56 to both sides. So I'm going to add 56t to both sides. Plus. So 9 plus 56 is 65t, which is equal to 8r. Okay. Then I'm going to divide both sides by 65. This is where if anything simplified, I would simplify. I cannot divide 65 by 2 or 4 or 8. So I'm just going to leave it as t equals 8r divided by 65. That would be my simplified answer. Okay, so when possible, simplify. All right, solve for, in this case, we want to solve for w. I need to first divide by x and get rid of that coefficient. That's going to leave me with the square root of w equals 2y divided by x. In order to get w by itself, I want to square it, which means I have to square this whole side. So that's going to leave me with w equals. And I can simplify this. Remember, I need to distribute to all 3. So 2 squared is 4, y squared, x squared. And that would be my final answer. All right, so those 6 problems on literal equations. The backside are problems that I found that kind of fit literal equations, but with the SAT in mind. So these are problems that I specifically pulled off of the SAT with manipulation of equations. Okay. It says a baker earned $7 an hour at Bakery Corp. How many hours would the baker work in a week to earn $332.50? Write the equation that represents the situation. So to write the equation that represents the situation, we would say something like $7 an hour means $7 times some amount of hours equals $332.50. So that would be the equation that models the situation. I could then divide and say x equals. So let's make this calculator a little bigger. Take 332.5 divided by 7. 47 and a half. So 47.5 hours. And I believe when I pulled this off the SAT, the only thing that they were looking for was this. Okay, next question. If A equals and 2A equals, what is the value of X? So they like these questions on the SAT. So notice that they're giving us the value of A. So we know that A is this. So we can substitute it in for A to figure out what the value of X is. So that means this would be 2 times 5 root 2 equals the square root of 2x. And our goal is to figure out what x is. So over here, if I have 2 5 root 2, that means I have 10 square root of 2. Instead of 5, I have 10 of them, equals the square root of 2x. I want to get x by itself, so I'm going to square this side. Be careful that you square this whole side. That means that I need to square both of these numbers. So 10 squared is 100. Square root of 2 squared is 2. So that's going to give me 200 equals 2x. Sorry, up here, this left us with 2x. Divide both sides by 100, or sorry, divide both sides by 2, and we're going to get that x is 100. Okay, let's try another one. Let's see. Given the square root of this minus x, k is less than 0, and x is 7. What is the value of k? So we're trying to figure out the value of k. This right here is very important. If we're talking about k is less than 0, then that means that k must be negative. Okay, we do know that x equals 7, so we can substitute that into our equation. So we have 2k squared plus 17 square root of this minus x, so minus 7, all I'm doing is substituting, equals 0. All right, if I want to solve this, I need to get the radical by itself, so I'm going to add 7 to the other side. It's going to leave us with 2k squared plus 17, the square root of this, equals positive 7. I can square the left side, which means I have to square the right side. That's going to give me 2k squared plus 17 equals 49. Okay, so I can see that this is quadratic because of k squared, but since there's only one k value, I don't need to factor. I'm just going to move the 17 and move the 2 and then take the square root. Okay, so I'm going to move the 17 first. That's going to give us 2k squared. If I subtract 17 from both sides, I get 32. I'm going to divide both sides by 2. That's going to give me a k squared equals 16. I'm going to take the square root of both sides. And when I take the square root of both sides, I get k equals plus or minus 4. Okay, now the thing that this problem in the SAT is looking for is they're trying to catch you and say that your answer is 4, because typically what we do is we take the square root of 16, we say that the answer is 4, we forget the plus or minus. And given the fact that they said k has to be less than 0, the value of 4 doesn't make sense. So the only one that actually does make sense is that k is negative 4. So they're really checking to see that you understand how to algebraically solve, but also that you understand that there's 2 answers here. Okay? And then we got 2 more. All right, this one says, your sister is selling Girl Scout cookies for $2.60 a box. Your family bought 6 boxes. How many more boxes of cookies must she sell in order to collect $130? So a lot of ways that you can go about solving this. This would be the algebraic way of setting up an equation to solve it. So we know it's $2.60 a box and your family already bought 6. So we would say $2.60 times 6 boxes, because that's what's already bought, plus $2.60 times some more amount of boxes has to equal 130, because that's what we have to collect. Okay, a lot of you guys would probably just multiply this here and subtract it from 130, which is the same. This is just the equation that represents the situation. Okay, so I can use my calculator, and I would say 2.6 times 6, so $15.60 plus $2.60x equals 130. Okay, we would subtract this 1560 to both sides, giving us 2.60x equals, so if I take 130, I subtract 15.6, I get $114.40. Divide both of these by 260. So let's see, divided by 260, and I get x equals 44. That's talking about boxes of cookies, so I'm just going to say 44 boxes. All right, last one. We won't need the calculator for this, so I'm going to get rid of it. Okay, this one says a website uses the formula below to calculate a seller's rating R based on the number of favorable reviews F and unfavorable reviews N. Express the equation in terms of the number of favorable reviews F. Okay. When it says express the equation in terms of the number of favorable reviews F, it's telling you that it wants you to solve for F. So this is very much similar to the first page where we want to solve the literal equation that has multiple variables for a specific variable. Okay, notice that there's F in both places. What you cannot do is this, then you're neglecting that N. Okay, remember, anytime you have a fraction, you should always get rid of the denominator. Since you're dividing by it, multiply by it. So I'm going to multiply by N plus F. On this side, that's going to cancel these. On this side, I'm going to also multiply by N plus F. Okay, that's going to leave me with N plus F times R equals F. Okay, at this point I still have F in two different places. I actually want to distribute, which is what we did. We did similarly something to this on the first side. So if I distribute the R, that's going to give me R times N plus F times R equals F. Okay, I want to solve for F. So what I actually need to do is I actually need to move this term over. Notice I have three terms. I need to move this term over to the other side since it has an F, and then I'll have two terms on the same side, both with an F. So that's going to give me R, oops, that's not R, R times N equals F minus F times R. And then this happened on the other side. We have two terms with F, we can factor it out. So we're going to be left with R times N equals F times, F divided by F is 1, FR divided by F is just minus R. So because I've factored, I've created multiplication. If I want to undo multiplication, I divide. I want to get F by itself, so I want to get rid of this 1 minus R. So I'm going to divide both sides by 1 minus R. Okay, that's going to leave me with F equals R times N divided by 1 minus R. Notice that F is by itself. There are no terms over here with an F. Again, I cannot cancel out these R's because then I would not be changing this 1. So this would be my final answer. Okay, your homework is worksheet number 1. And it's going to have a lot of the front page is going to look just like the 6 problems that we did in the notes. It's just going to have 9 of them. And then it's going to have problems like this where similar to what we just did. So one of those, and then a couple on the back that I'll have you guys write some equations. These are questions, again, that I saw in the SAT. So the way that this is worded, and I pulled these right off of practice SATs. So yeah, so we won't get as much time to practice SATs in the classroom probably, but this will hopefully give you that same type of practice. And if you have questions on these, let me know on Google Classroom, and that's what we can kind of spend some time on Google Hangouts with as soon as I figure it out. Okay, go ahead and look for the next video. Bye, guys.